Algebra 2. I hope you guys are having a fantastic day. We are moving on to 3-4, and 3-4 is all about factoring polynomials. There's two different videos, so the first one, this one, is going to be pretty short, I think. It's just on factoring sums and differences of cubes, so this is like a special case. And then the next video is going to be a theorem, and then factoring by grouping. So this is just a special case, just like a difference of two squares, right? So if we have something like x squared minus 4, right? Both of those are two perfect squares, so that factors to x minus 2 times x plus 2. And it's a special case, so it's got a special quick way of factoring. And so sums and differences of cubes are similar. They just kind of have a formula that help you factor it a little bit. And so we're going to go over that. So if you have a sum of cubes, so something cubed plus something else cubed, or something cubed minus something else cubed. Okay, so if you have a sum of two cubes, a cubed plus b cubed, that just factors to a plus b times a squared minus ab plus b squared. And so it looks like that. Okay, so we'll do a couple examples so it's easier for, it makes a little more sense, but it has to be something cubed and something else cubed. You can't have like, it can't be 2a cubed or something, because that 2 is not cubed. Now if it's 2a cubed, then that is, and you can use the formula. Okay, the difference formula is almost exactly the same thing, except this is a minus and that's a plus. So pretty easy to remember. If you remember one of them, you can just swap the plus and the minus for the other. So there you have it. So I'm just going to do a couple examples. I would say watch the first one, and if you get it, cool. Try the other ones, and then just just check your answers with the rest of the video. And if you need to watch all of them, then watch all of them. Okay? Yay! So this first one's pretty simple because you have 1 plus y cubed. 1 is a perfect cube, right? 1 times 1 times 1 is equal to 1. So I can actually just write that as 1 cubed plus y cubed, right? And then I can just use the formula. Now keep in mind that if you have a sum of two perfect cubes, it's so if I have a cubed plus b cubed, and that equals a plus b times a squared minus ab plus b squared, right? And so in this case, a is equal to 1 and b is equal to y. So I just plug those into the formula. So it's just equal to 1 plus y times 1 squared, which is just 1, minus 1 times y, which is just y, plus y squared, which is y squared. Yay! Okay. So 1 cubed plus y cubed is equal to 1 plus y times 1 minus y plus y squared. And that's it. If you can factor this thing, then you can go ahead and factor it and make it a little bit nicer. So we should check and make sure that's not factorable. But generally speaking, that's kind of how you do it. I like it to be in like standard form if we can. So I made it just y plus 1 times y squared minus y plus 1. But it's, either one would be fine. And then you want to check, is y squared minus y plus 1, is that factorable? And in this case, right, there's nothing that multiplies to positive 1 that adds to negative 1, so that's not factorable. So you leave it as is, okay? The hardest part probably of this is just figuring out how to write it as cubes and like deciding whether or not it actually is a sum or difference of cubes. But once you see a couple, you'll kind of start to get the hang of it, okay? So let's try number 2. We have y to the 6th minus z cubed. Now, this lesson is about sums and differences of cubes. So would I give you a problem that's not a cube problem in this section? No, probably not. So this one you have to try to figure out, how do I write it as a cube? Now y to the 6th is not, right now it's not written like a cube. Z to the 3rd is, so that one we can keep the same. And this is a minus, so instead of the a cubed plus b cubed, we want the other formula, which is the minus, and that's the one where we just switch the first two pluses and minuses. Okay? So I just switch that to a minus and that to a minus, and that to a plus. Okay? Which is the same thing as that formula that I gave you in the beginning right here. Okay? Because that's a difference of two perfect cubes, not the sum. Right? We're subtracting now. Okay? So y to the 6th. How do we write that as something to the 3rd power? So we're trying to figure out y to the 6th. We want it to look like something to the 3rd power. And so we want to figure out, okay, what could I put in there that's going to be equal to y to the 6th? If you think about your exponent rules, right, if you have a power to a power, right, whatever this power is to another power, they multiply, right? So this times this has to be 6, so that would be squared. So this is going to be, your question mark is y squared, okay? So I can just write it as y squared to the 3rd power, so that I have a difference of two perfect cubes. Okay, so now in this case, my a term is y squared, right there. And my b term is z cubed, okay? And I'm using the difference formula. So I just plug those into the formula. So where I see an a, I plug in y squared. Where I see a b, I plug in z. And first go of it, I get this y squared minus z times y squared squared plus y squared times z plus z squared. Okay, and then you can simplify that a little bit, and that's how you factor a cube. All right, go ahead, try the next two, 3 and 4 on your own, and then you can check your work with the answer that I'm going to put down for you. Okay, so for 3, you want to write 8y cubed as 2y cubed, okay? So that's equal to the same thing, right? Because 2 cubed is 8, and y cubed is just y cubed. And 27 you would want to write as 3 cubed, because 3 times 3 times 3 is 27. So then this is your a term, this is your b term. We're using the sum formula, so it just ends up to be 2y plus 3 times 2y squared minus 2y times 3 plus 3 squared. And then this is your final result once you simplify a little bit. Okay, and then number 4 is a little bit trickier, right? Because you don't have an obvious power of 3 here, or multiple of 3. But both of these terms have a 3x that you can pull out. So I pulled out a 3x first, and what I'm left with is x cubed minus 8, right? Because 3x to the 4th, if I pull out a 3x from that, that's just x to the 3rd. And then 24 divided by 3 is 8, and I pull out an x. Okay, so then I have x cubed minus 8. That is a perfect cube, so I have x cubed minus 2 cubed on the inside, and then I can factor this. Don't lose your 3x, okay? A lot of people do that. That is still part of your factored answer. But then you just want to factor this using the difference formula. So then you have 3x times x minus 2, right, where your a is x and your b is 2, x minus 2, times x squared plus 2x plus 4. Okay? And then that's it. So there you go. I will see you later.